Hypersonic speed, Mach 5 and beyond, is the new frontier in global defense technology, changing everything.
The immense heat and drag at these speeds present monumental engineering challenges that must be overcome for success.
New materials are essential for survival. They must withstand temperatures higher than molten lava during flight. The Scramjet engine, a technological marvel, compresses air without moving parts, propelling the future of flight.
Preparations for the maiden flight are complete. Every system must perform flawlessly under extreme pressure, now.
On the launch pad, the missile symbolizes decades of intense research, poised to redefine strategic capabilities. T-minus 10 seconds and counting. The entire team holds its breath, focused entirely on the upcoming ignition sequence.
Liftoff. A brilliant flash illuminates the morning sky as the missile begins its swift ascent toward target velocity. Separating from the booster, the revolutionary Scramjet takes over, pushing the vehicle into true hypersonic domain rapidly.
Mach 5 achieved. The impossible is now reality. This speed ensures minimal reaction time for global threats.
The thermal shielding holds strong. Advanced materials protect the vehicle from immense heat friction effectively.
Stealth at this speed means defenses have almost no time to react. It is virtually invisible until impact.
Unpredictable maneuvering makes interception nearly impossible, adding a layer of crucial defense superiority globally.
The advent of these weapons reshapes global power dynamics, forcing nations to rapidly rethink their existing defense strategies.
Rapid global strike capability is not about aggression, but about effective deterrence, ensuring swift response options.
Unconventional missile defense systems struggle profoundly against the blistering speed and low trajectory of hypersonic flight.
Achieving pinpoint accuracy at Mach speeds demands state-of-the-art guidance systems and unparalleled navigational precision.
Every component must be rigorously tested to guarantee it survives the turbulent, high-stress environment of the boundary layer flow.
We are pushing the limits further, and the next test will expand the flight envelope into more challenging, extreme conditions.
Soaring above conventional flight paths, the missile cruises, a silent, swift, and highly formidable force in the upper atmosphere.
This new era demands fresh diplomatic approaches and robust international treaties to manage the delicate hypersonic arms race.
Billions of dollars are being invested globally. The cost of achieving this dominance is staggering, but deemed necessary. The surrounding plasma sheath blocks communications. Overcoming this blackout is a critical challenge for effective command and control.
The software must react in milliseconds to tiny disturbances, ensuring the precise trajectory is maintained successfully and rapidly.
Analyzing the flight data reveals exceptional stability, even when performing the most extreme and demanding evasive maneuvers.
In the final phase, the missile executes its terminal maneuver, demonstrating unparalleled accuracy and devastating effect quickly. Success. Decades of dedication and tireless effort culminate in this single, monumental, technological achievement today. With great power comes profound responsibility, and we must ensure this technology is a shield, not a weapon of first resort.
Beyond military application, this technology promises a future where global travel could be achieved in mere minutes, effortlessly.
The hypersonic revolution is here. The world of global forces will never look the same again.
Precise fuel mixture injection must occur within milliseconds. This ensures stable, sustained combustion at extreme airspeeds.
Accurate data relies on perfectly calibrated sensors capable of enduring and reporting back the massive thermal forces.
Adversaries are already developing advanced detection methods. The race for counter-hypersonic defense technology has already begun.
Piloting a vehicle at Mach speed requires split-second decisions and absolute mastery of the non-linear aerodynamics involved.
Two main types exist. Boost glide systems offer speed from high altitude, while air breathers sustain it lower down.
Ground testing the Scramjet is critical. It proves the engine can achieve stable combustion before actual high-speed flight.
The thermal output is enormous. Careful monitoring of all heat-resistant structures is vital for long-term viability.
When can we expect full operational capability? The timeline is classified, but progress is accelerating rapidly worldwide.
Transparency in testing and clear communication can reduce the risk of miscalculation and prevent global forces from escalating.
The unpredictable skip-glide trajectory makes intercepting these weapons akin to shooting a bullet with another, fast bullet.
Nanotechnology provides a feather-light yet incredibly robust thermal protection system, capable of surviving extreme heating easily.
Flameprint. The nose cone houses vital sensors. Its installation required absolute precision to maintain the...
Attention team, the transport sequence begins shortly. Maintain vigilance and adhere strictly to all established safety protocols.
This technology stands on the shoulders of giants, a culmination of decades of relentless, pioneering research into high-speed flight.
Breaking the sound barrier was yesterday's challenge. Today, the Mach 5 barrier is the ultimate new technological threshold quickly.
Defense against this speed requires innovative, space-based early warning systems, demanding total integration and constant vigilance.
The mission is a ballet of engineering, from powerful boost to sustained hypersonic cruise and final, accurate descent.
Recognition for the team's breakthrough achievement underscores the significance of this technological leap for global security.
This is just the beginning. The next generation of engineers must push the boundaries of physics even further now. Hardware recovery confirms all data points. The vehicle performed exactly as modeled in the challenging upper atmosphere.
The ablative coating sacrifices itself layer by layer, dissipating the extreme thermal energy generated by air friction. Optimizing the airflow intake is crucial for scramjet performance, ensuring the necessary pressure is achieved consistently.
Tolerance for error is near zero. The complex engine parts require flawless machining and absolute structural integrity today.
Compared to older ballistic missiles, the hypersonic vehicle is sleeker, faster, and exponentially more technologically advanced now.
Political debate centers on use case scenarios. Ensuring responsible policy guides this immense destructive military power is paramount.
To witness that speed is to see the physical limits of our understanding of physics being rapidly overcome and redefined now.
Flying low and fast, it uses terrain masking to defeat conventional ground-based radar systems easily, maintaining stealth and surprise.
Managing the enormous shock waves generated at Mach 7 requires sophisticated algorithms and continuous aerodynamic adjustments during flight.
The flight software needs to anticipate thermal spikes and adjust the trajectory instantly to prevent catastrophic system failures.
This extraordinary achievement is the result of thousands of hours of intense collaboration across multiple engineering disciplines seamlessly.
Safety is paramount. The advanced fuel and propulsion systems demand meticulous adherence to all established operational protocols immediately.
Prompt global strike capability means forces can react to emerging threats anywhere in the world within the hour effectively.
International reaction is mixed. Some applaud the technology, while others express grave concern over the potential for an arms race now. This technology is simply physics in action. Imagine the possibilities when your generation...
Each test generates terabytes of data. Careful organization and analysis are crucial for continuous system improvement and iteration.
Air is compressed, fuel is injected, and the resulting combustion propels the vehicle forward at speeds previously considered impossible.
This technology represents immense power. We must always be mindful of the responsibility that comes with unparalleled speed and capability.
The sole purpose of this weapon is to deter aggression by presenting an overwhelming, swift, and undeniable response capability.
Public opinion is divided. Some support the defense investment, while others question the massive cost and the ensuing global arms race.
The work never stops. Even after this breakthrough, the next iteration of hypersonic flight is already being intensely conceived now.
Precision is automated. Robotic systems ensure every weld and component placement meets the impossibly high standard precisely. The sophisticated thermal management system actively adjusts to the friction, minimizing the detectable infrared signature significantly.
The airborne launch test is crucial for validating separation dynamics and ignition under real high-altitude conditions successfully.
The speed forces a radical change in operational doctrine. Planning and execution windows have dramatically shrunk worldwide.
Intelligence reports confirm that multiple global powers are rapidly accelerating their own parallel hypersonic weapons development programs now.
Aerodynamic flutter at Mach speeds can tear the vehicle apart. Solving this complex oscillation problem demands intense focus quickly.
We must know the breaking point. Destructive testing reveals the ultimate limits of the new high-strength composite materials effectively.
The intercontinental range gives unprecedented reach, ensuring that no potential target remains safe or entirely unreachable globally now.
Airspace clearance is confirmed. All civilian and military traffic must be redirected before the next launch window opens successfully.
Supercomputing allows us to run millions of simulations, refining designs faster than ever and accelerating the entire development cycle significantly.
A single loose connection can be catastrophic at Mach speeds. Every wire harness must be meticulously checked and secured repeatedly.
Continued funding is not optional. It is essential to maintain a credible deterrent and safeguard our national security interests globally now.
The project provides thousands of high-tech jobs,
fueling a significant economic boom in the specialized aerospace and defense sector quickly.
Controlling a hypersonic vehicle is an art. The reaction time required demands near instantaneous decision-making and total confidence always.
The difference is vast. Slower cruise missiles are easily tracked. Hypersonic weapons fly higher and exponentially.
Every component from every supplier must meet an unprecedented level of quality and consistency for complete mission success.
Root cause analysis is crucial. Even a minor sensor malfunction can reveal critical design flaws that must be immediately addressed systematically.
The speed shrinks the battlefield. Future conflicts will be decided with unprecedented swiftness, demanding continuous readiness and awareness.
The hypersonic revolution is a reality, permanently altering the delicate balance of military power and global strategic calculations forever.
Optimizing the shape of the vehicle is an ongoing process, seeking marginal gains in lift and drag reduction constantly.
Additive manufacturing allows for rapid prototyping and creates complex internal structures that were impossible to machine conventionally.
The flexible flight path allows for immediate course alteration, making pre-calculated interception routes practically useless strategically.
The plasma layer causes a radio blackout, a serious challenge for real-time control.
Even with this capability, respecting international airspace and boundaries remains a crucial foundation of responsible global conduct.
Debate now shifts. Should more resources be allocated to developing a viable, high-speed defense system to counter similar threats?
The sensitive navigation unit must be perfectly isolated from the extreme vibrations and thermal loads experienced during the flight duration.
Simulate the flight conditions, the systems must endure incredible G-forces and violent vibrations without any measurable performance degradation.
Advanced onboard sensors provide real-time targeting updates and course corrections, guaranteeing accuracy throughout the entire mission profile successfully.
That first liftoff was not just a test. It was the physical realization of a previously impossible dream, taking flight rapidly.
We must anticipate countermeasures. The design must be continuously iterated to defeat new and emerging detection and interception technologies.
Failure is our best teacher. Every test setback provides essential data points that ultimately lead to a stronger, more robust design.
Maintaining operational readiness is paramount. This technology requires an elite, highly trained group of professionals for successful deployment.
This new race for speed echoes the geopolitical rivalry of the space race, defining a new era of global competition for dominance.
The fuel delivery system must maintain flawless pressure and flow rates despite the extreme external G-forces and rapid trajectory changes.
Mastering the emergent procedure at high Mach is a non-negotiable, the first absolute priority successfully.
High cycle fatigue due to intense heating and cooling cycles is a critical factor limiting the overall lifespan of the entire airframe.
All electrical systems are nominal, ready for launch sequence activation. The final check is confirmed and the power is stabilized.
Cybersecurity is an indispensable layer of defense. Protecting this technology from external espionage and internal sabotage is vital always.
The potential for this technology to proliferate globally raises serious policy concerns regarding future international stability and peace.
Supersonic combustion is a controlled explosion, a delicate balance of flow and fuel that maintains the required thrust at extreme speed efficiently.
The control fins must withstand enormous pressure. Even a minor instability at Mach 5 will cause complete catastrophic flight failure.
Test complete. Shielding.
Shielding effective.
Electromagnetic shielding protects the sensitive electronics from the extreme forces and energy field. The radome must be optically clear, highly durable, and completely impervious to the intense heat and the surrounding plasma generated constantly.
Rapid deployment requires a highly streamlined and resilient logistical chain capable of moving this advanced system anywhere instantly.
The industry faces a massive skills gap. A highly specialized workforce is urgently needed to support this rapidly accelerating technological revolution.
Conventional radar struggles against this speed. Detecting and tracking this target requires a fundamental overhaul.
Sharing these technical findings within security limits accelerates the pace of innovation across the entire scientific community globally.
Scorching indicates the enormous thermal energy. Analyzing this damage provides crucial data for improving the next generation's defense.
The cycle repeats. Refine, test, analyze, and relaunch. And the pursuit of ultimate speed and...
From the chase plane, the speed is simply breathtaking. A fleeting glimpse of a truly awesome, controlled technological force in flight.
Verifying these systems is challenging. New, robust verification methods are urgently required for future arms control treaties effectively.
History shows that every significant technological leap in weaponry fundamentally reshapes global conflicts and long-term strategic relationships.
Testing new ceramics against intense laser energy is critical. Ensuring the vehicle can resist future directed energy weapons is vital.
Reducing the acoustic signature is another layer of stealth. Less noise means a significantly reduced detection range overall, substantially.
Tomorrow's hypersonic technology world where intercontinental alliance can be achieved.
Technology is a testament to the thousands of dedicated minds and the immense sacrifice of past generations of brilliant scientists.
Rapid global transport, driven by hypersonic technology, could fundamentally disrupt established global supply chains and economic models quickly.
The math behind Mach 7 flight is nonlinear and extraordinarily complex. Every detail must be perfect to ensure stability always.
Solving the chronic combustion instability problem required tenacity, patience, and brilliant minds working together seamlessly toward success.
The fluid lines operate under extreme pressure. Ensuring absolute integrity against any minute leaks is vital for mission safety and success.
Retargeting the weapon mid-flight provides exceptional mission flexibility, ensuring it remains a highly adaptable and potent strategic asset.
Operating at the edge of the atmosphere, where the air is thinnest, presents unique challenges for engine performance and stable flight control.
The same technology could revolutionize space access, dramatically reducing the cost and time.
Environmental concerns exist. The long-term impact of frequent, high-altitude hypersonic exhaust plumes on the sensitive upper atmosphere is still unknown.
Protecting these secrets is as critical as the design itself. The security of all intellectual property must be completely impenetrable always.
A tiny thermal anomaly on the nozzle suggests a minute leak. Every single component must perform perfect.
The physical inspection confirms the minor issue. Immediate repair and reinforcement of that specific engine section are required immediately.
Defending against this speed requires a coordinated, multi-layer approach.
This technology is a game changer of the magnitude of radar's invention. It creates a new strategic paradigm that must be overcome quickly.
Does this absolute speed capability truly enhance or instead significantly destabilize the delicate...
The missile surfs the atmospheric density, constantly optimizing its altitude for both speed and efficient scramjet operation effectively.
Flawless structural joining is achieved through robotics. The engine structure must be absolutely perfect before the next major flight test begins.
The final walk-around is essential. Every single external panel, bolt, and sensor is meticulous.
Hypersonic weapons significantly enhance conventional deterrence, but demand a complete reevaluation of all future escalation pathways worldwide.
Post-test recovery is a precise, challenging operation. Every piece of specialized debris must be located and recovered carefully and quickly.
The missile's high speed, small cross-section, and reduced heat signature all combine to make it truly...
These small victories keep the project moving forward. Late nights and hard work are fueled by passion for this ultimate breakthrough.
The integrity of the raw materials is non-negotiable. Absolute purity and consistency are essential for surviving the immense high stresses.
Witness the speed,
A perfect flight profile demonstrating the overwhelming, unstoppable force of the hypersonic.
The next test will push the missile to its absolute limits, challenging the flight control system with an unprecedented low-altitude profile.
Nations are dramatically reallocating defense budgets, signaling a significant long-term commitment to hypersonic and counter-hypersonic development programs.
Political divide remains sharp. Is this a necessary shield for peace or a grave new catalyst for further inevitable global conflict?
Imagine the air itself as a high-speed piston. That is the simplest way to understand the phenomenal mechanics of the advanced Scramjet engine efficiently.
A single microcomponent failure can compromise the entire mission. Every single circuit board must be flawlessly executed and tested rigorously.
The shockwave pattern is an invisible shield, but it also creates immense, damaging pressure waves that must be carefully managed actively.
All downrange tracking stations report clear reception and full operational status. The communication network is fully confirmed and ready now.
Building an interceptor missile that is both fast enough and maneuverable enough to catch a hypersonic target presents an extreme technical challenge.
The investment is staggering. The perceived strategic benefit is deterrence, and invaluable. But
This is the pinnacle of our engineering, a testament to human ingenuity in the realm of speed and ultimate...
Fluffless. Finite element analysis models predict the exact structural load. This ensures that no joint or component will fail.
These specialized, interlocking ceramic tiles manage the incredible external temperature, acting as a crucial heat shield for the inner workings.
Virtual reality allows pilots to master complex, high-speed maneuvers safely, building the necessary muscle memory for unpredictable threats.
A clear global dialogue is urgently needed to establish new international norms and strictly define.
Secrets of hypersonic flight are the most sought-after intelligence on the planet, and counter-espionage efforts are now at unprecedented critical levels.
At this speed, system reliability cannot be just good. It must be completely flawless, aiming for the absolute maximum acceptable level of performance.
New high-temperature sensors must provide accurate readings while themselves enduring the blistering thermal environment continuously and successfully.
No conventional static defense grid can stop it, and the overwhelming speed allows the missile to bypass it.
The data confirms the flight control algorithms performed flawlessly, maintaining absolute stability throughout the entire extreme mission profile accurately.
The journey of discovery is a constant, relentless grind, fueled by unyielding curiosity and the dedicated pursuit.
The foundation is laid. Future application includes space defense and advanced anti-satellite capabilities, dramatically extending global reach.
The threat has spurred collaboration. Allied nations are pooling resources to jointly develop a robust, shared defense system solution immediately.
Stage separation is a high-stakes moment. The explosive bolts must fire precisely, ensuring the Scramjet engages perfectly and quickly.
The final software upload is critical. This patch contains weeks of refined algorithms for trajectory correction and real-time flight stability.
watching it fly is an honor and a profound responsibility, and we are holding the future of global defense in the palm of our dedicated hands.
Non-proliferation efforts must be rigorously enforced. The spread of this technology to unstable nations poses an immediate and grave global threat now.
Public debate rages globally. Fear of an arms race competes with the undeniable desire for absolute, unmatched national security and ultimate dominance.
The next leap requires an order of magnitude increase in power density. A compact, powerful energy source is the next great technological hurdle quickly.
Witness the power of the Scramjet. A continuous, controlled explosion, propelling the vehicle into the realm.
Electromagnetic compatibility testing ensures that no internal systems interfere with the highly sensitive guidance and communication electronics successfully.
Designed for ultimate flexibility, the missile can be launched from air, land, or sea.
Bravely. The system boasts an exceptionally rapid turnaround time, minimizing the window between missions and maximizing overall.
The ethical use of such decisive power requires absolute moral clarity and constant consideration of the profound human cost involved, constantly.
The United Nations calls for immediate, verifiable dialogue on controlling the proliferation of these destructive, high-speed weapons globally and now.
Understanding precisely why a part failed is the single key to designing a stronger, more reliable system for the next critical flight.
The regenerative cooling system circulates fuel to cool the engine walls, This essential heat exchange is absolutely critical.
Every element of the design, from the coating to the flight profile, is engineered for maximum stealth and minimum detectable signature constantly.
Terminal phase maneuvering requires delicate, near-imperceptible control inputs. Large movements will cause immediate, catastrophic flight instability quickly.
Hypersonic speed is the ultimate deterrent, the strategic equivalent of a checkmate piece that prevents any opponent from making a successful move.
From concept to flight, this project represents a monumental, collaborative leap in every field of advanced engineering and materials science globally.
This success belongs to every single person and their families, and your sacrifice and hard work made.
The future of this program depends on the next generation mastering these complex, high-tolerance manufacturing techniques absolutely and consistently.
Continuous, high-speed telemetry ensures ground control maintains situational awareness, guiding the vehicle even through the entire plasma blackout successfully.
Collecting atmospheric data in the projected flight path is essential. This ensures this.
Electronic warfare is critical. Jamming enemy sensors and disrupting their guidance systems will provide a crucial new operational advantage.
Program delays cost millions daily. Political infighting and budget sequestration seriously impede the necessary rapid pace of technological development now.
The fuel pump must deliver thousands of liters per minute under immense pressure. Its flawless operation is non-negotiable for sustained flight.
The system is nominal and fully green across all critical.
The nose cone glows red hot. The visible thermal stress confirms the incredible friction and the unbelievable performance of the specialized materials successfully.
Maneuver confirmed. The missile successfully executed the high G turn, validating the complex control algorithms under the most extreme conditions now.
Deterrence is a delicate balance. This speed is designed to ensure that the cost of aggression will always remain unequivocally too high for any risk.
The next critical step is to find diplomatic pathways that prevent the rapid technological advancement from escalating into actual global conflict.
Continuous material science breakthroughs are essential. We are constantly searching for new, stronger ceramics capable of enduring even higher temperatures.
The flight data recorder is the mission's ultimate source of truth. Every millisecond of that analyzed.
The missile is not bound to a single speed. Its variable Mach capability allows it to dynamically optimize.
Terrain following at Mach speed is an extremely demanding task. The control system must react instantly to avoid any sudden ground proximity.
This technology provides a necessary counter, ensuring overwhelming response options are available across the complete strategic spectrum.
The entire facility is a fortress. Layers of security protect the highly sensitive research from constant, relentless threats of espionage and theft.
The initial boost provides the incredible momentum required. This powerful, first-stage rocket is the key to its...
He has approved the bank rise. Sustained Mach thrust confirms the engine's efficiency. The Scramjet exactly as predicted.
Operations. The inertial guidance unit is the brain. Its flawless calibration ensures the weapon navigates perfectly without...
The onboard AI allows autonomous flight decisions, adapting instantly to changes in the environment and maintaining the mission goal independently.
Consistent, detailed maintenance is non-negotiable. Preserving the peak performance of this incredibly complex system is...
The complex global logistics chain is designed for rapid deployment, ensuring the weapon can be anywhere in the world within just a few hours readily.
Revolution is a powerful testament to the successful collaboration between the government and a highly specialized, dedicated private industrial base.
The next generation of vehicles will require even more radical breakthroughs, potentially moving toward controlled nuclear fusion for ultimate power.
Internal thermal management is just as crucial as the external. Preventing electronic overheating is vital for all flight longevity and ultimate reliability.
The unpredictable, high-G maneuvering capability makes tracking and successfully intercepting the missile practically an impossible task for any opponent.
Analyzing the inputs confirms the system's responsiveness. The controls are extremely sensitive and demand absolute precision from the operator constantly.
A shared international code of conduct is necessary, and we must collectively ensure an ethical use.
Global reaction is a mixture of awe, concern, and intense competition, reflecting the immense gravity of this ultimate new...
Active cooling technology is essential for the nose cone. Efficiently dissipating the massive heat from atmospheric friction is absolutely vital for mission success.
Umbilical disconnect confirmed clean. The missile is on internal power and ready for the launch sequence to officially begin immediately and successfully.
Mach 10 achieved. The missile pushes past all previous limits, entering a realm of speed previously thought entirely impossible to maintain consistently.
Physical evidence of success. This vehicle survived the most intense environment possible, bringing back crucial, invaluable data sets.
Neglecting counter-hypersonic defense is a catastrophic strategic failure. Sustained investment is absolutely essential.
This breakthrough inspires a new generation, pushing young minds towards science and engineering to solve the next wave of impossible global problems.
The ultimate goal is commercialization. Imagine a fully reusable hypersonic aircraft.
Behind the immense speed lies the collective human effort, dedication, and incredible sacrifice of a truly brilliant
engines. Working in confined spaces demands exceptional dexterity and focus. Every replacement must be absolutely
We minimize risk by meticulous planning. Every high Mach test preceded by countless simulations.
Tracking other hypersonic programs is akin to searching for a needle moving at Mach speed, and this demands entirely new and innovative intelligence methods quickly.
This vast, complex project has created thousands of highly skilled, well-paying jobs, stimulating an economic boom in the...
The final, subtle tweaks to the fluid dynamics unlock that last crucial percentage of performance and sustain.
Every external panel must be perfectly flush to the skin. Any tiny gap can lead to catastrophic, turbulent airflow separation at high Mach speeds.
Never give up on a problem. Every setback is a lesson, and relentless perseverance is the single key to all ultimate technological triumph.
Speed, stealth, and pinpoint accuracy define this new era. The hypersonic revolution represents the absolute ultimate.
Responsible global leadership is paramount. Only through collaboration can we manage the profound strategic implications of this.
Critics argue the immense cost could be better spent elsewhere, questioning the overall necessity
and the true destabilizing global effect of the investment.
And the ability to learn from every setback, large or small, is the very definition of true engineering progress.
Fuel lines must withstand pressures far beyond the expected maximum. Over-engineering is the necessary guarantee of operational reliability.
Multiple integrated guidance systems.
Practicing engine failure mid-flight is vital. The ability to successfully manage a critical emergency at Mach speed determines ultimate mission survival and success.
Or starved. The only way to successfully defeat speed is with superior heat, the next gen of defense.
Scaling up production capacity requires an enormous investment in automated manufacturing, ensuring rapid, large-scale deployment capabilities are always available.
Optimizing the fuel injector nozzle is an art and a science. It must create the perfect fuel-air mixture.
Engage Labs. The breakthrough was not a single moment, but thousands of hours of relentless, dedicated effort and personal sacrifice from...
Even a microscopic imperfection in a high-temperature seal can lead to total, catastrophic engine failure.
Flying close to the surface minimizes radar detection. The boundary layer flow reduces the overall signature successfully and significantly.
We are going live on the simulated command test. All personnel maintain absolute vigilance and adhere.
Strict export controls are the first essential line of defense against the widespread and potentially disastrous proliferation.
The latest test flight was an unequivocal success, marking a definitive and complete achievement in the entire complex history of advanced aerospace engineering.
Harnessing the power of the shock wave to compress the air is the genius behind the Scramjet.
The fuel pump performance was absolutely flawless. It maintained the required flow and pressure despite all the extreme maneuvers and immense G-forces.
In a rapid response scenario, the speed and accuracy of the weapon dramatically shorten the decision cycle.
This technology will be studied for generations. Its legacy is not just speed, but the sheer scientific and engineering audacity of human endeavor.
The future of this technology lies in the hands of the young men and women who possess the necessary intellect and mental agility to operate it effectively.
The next global challenge is diplomacy, successfully managing the fallout and the international arms race caused by this definitive breakthrough is essential.
Personal sacrifice is immense, but the support of family makes every single late night and every single difficult challenge infinitely more bearable.
Engineering and coding are the new superpowers. They give you the tools to literally design and build the future you absolutely wish to see for yourself.
Manufacturing requires entirely new methods. High-precision robotics and automated systems ensure the necessary flawless build quality for all parts.
Addressing the world about this power is a serious responsibility. The message must be one of deterrence, not one of immediate aggression or pure military might.
The cost is high, but the strategic value as a credible deterrent against aggression is actually fundamentally priceless for global stability and security.
The ethical debate around absolute speed continues. The humanitarian implications of such decisive and overwhelming.
The engine core is the heart of the system. Its final installation requires absolute precision and complete and total commitment from all present teams.
Every single electrical connection must be triple-checked. The operational environment will even the most minor and
The very definition of controlled power. Sustained supersonic combustion generates the immense thrust required to achieve and maintain ultimate hypersonic velocity constantly.
This technology should eventually serve humanity. The speed that now enables defense will one day connect all the people of the world effortlessly.
We must be honest. Defense against this speed is all possible. A complete technological...
High-level government oversight underscores the profound strategic importance of this project to the nation's entire defense posture globally.
From this vantage point, the true reach of the technology is evident. The world is incredibly small at these immense, unprecedented speeds.
Absolute cleanliness is mandatory. Even a single dust particle could potentially interfere with the highly sensitive final guidance system electronics.
Compared to a commercial airliner, the hypersonic missile is a blistering, completely silent blur.
We are today's aviation pioneers. We carry the same torch as the very first pilots who surprised us.
Final go for launch.
This test is a critical milestone, confirming the ultimate operational readiness of the system and all its integrated subcomponents.
The emotional outpouring confirms the immense pressure. Success in an incredibly changing field is...
Liftoff. A spectacle of raw, controlled power, defining the new ultimate limit of speed.
Peak performance confirmed, the engine achieved maximum predicted efficiency, validating all of our extensive and highly complex fluid dynamics models completely.
The first priority is to secure the data. Every single millisecond information is absolutely crucial for continued analysis.
The new reality. Any point on the globe is now reachable within minutes.
The weight of this incredible speed is not the physical force, but this profound...
This technology guarantees an undeniable, swift response capability, which is the very ultimate foundation of...
From challenging concepts to supersonic reality, the hypersonic revolution permanently reshapes the world of global forces.
This is a true team victory. The collaborative genius of every single engineer and scientist is...
Knowing my hands touched a system that flies at Mach speed fills me with a truly profound and ultimate sense of personal and professional achievement.
Speed, stealth, and absolute precision. These three words define the new, ultimate era of global.
We build the shield for the next generation. This technology ensures that our nation remains safe, strong, and...
True power is not merely capability, but the wisdom and absolute moral restraint to use that great, decisive...
The hypersonic revolution is not the end, but the very first beginning of a faster, more complex, and technologically demanding future for all of us globally.
The search for ultimate speed never truly ends. The next, even more complex challenge awaits.
Solving the world's most difficult technical problems requires the absolute best and most dedicated minds from every single corner of the planet working together.
Flying into the sunset, the missile represents the ultimate intersection of human scientific ambition.
The success is the team. The trust and commitment between every member is truly the strongest material in the entire world, without exception.
Let the speed be a testament to our resolve, a silent, swift, and undeniable promise that absolute peace is all.
The hypersonic age is upon us. The world must now navigate this new reality with immense caution, profound diplomacy.
The story of ultimate speed is the ultimate story of human innovation, relentless dedication, scientific passion. Stealthier than stealth, faster than fast. The hypersonic missile revolution, an ultimate defining moment.